Hi, this is Margo. This is Sunday evening, April the 5th, 2020, and I hope everyone is doing as well as possible. And we're going to be looking at methane and just basically doing a climate update and doing our weekly NOAA methane update and looking at some sea ice, and I'm going to present an article tonight and some earthquakes. So let's get going. So let's get started with climate reanalyzer 2-meter temperature anomaly from today, Sunday the 5th. We're seeing a lot of red in the Arctic and a lot of red up here in Siberia, and just a little bit of blue left over here by Svalbard, and a little bit of blue in Greenland. And that cold air is dissipating out of Canada. Still quite a bit of blue and some light purple, but the really cold air, it's really dissipating. So what we can see is worldwide the temperature is up 0.6 C higher than normal. The northern hemisphere is up 1.1 C. The Arctic has really jumped up since the last couple of days, and it's at plus 4.1 C. We don't normally see it this high this time of year, but it does fluctuate. But because we're seeing so much warmer than normal up here on the north coast of Canada and Greenland, and also over here in northern Siberia, and Alaska is in the red zone too. So that's about 20 degrees warmer than normal. So that's causing that 4.1 C higher than normal reading for the Arctic. The tropics are up 0.7 C. The southern hemisphere is up 0.1 C. And the Antarctic is at a minus 0.8 C, so it's lower than normal. So here's the global view. So we can see a lot of red over the Arctic, just kind of spreading out and then just stretching across Siberia here. Now let's look at the NOAA data. This is from yesterday, the 4th, for the 477/469 millibar reading. From the Met-OP1 satellite in the morning, the mean was 1892 parts per billion, and the high reading was 2427. We're seeing pink down way south in the globe, just above the Antarctic there. And in the afternoon, the mean was 1891 and the high reading was 2305. And in the Met-OP2 satellite in the morning, the mean was 1866, the high reading was 2316. And in the afternoon, we have some missing data, but we'll take what we've got. The mean was 1876 and the high reading was 2270. So we're seeing it pink over the Antarctic there as well. Here's our spreadsheet that we're working from, and the charting. Now I've been tracking this since March the 1st of last year, 2019, and so here we are on the weekly basis. Here it is from yesterday. I added up all those numbers I just read off and divided by 4, and the mean for this level is for yesterday and for this week was 1883.75 parts per billion, and it's showing that it's increased from the week before by 1 part per billion. And so here's the chart over here. it took a huge leap at 4.75 parts per billion last week, and then this week it's still gone up, but just 1 part per billion. And so just in this year of tracking from February 29th, which is where it'd be started the new year that we're tracking, just since then it's gone up 7.75 parts per billion. And since March the 1st of 2019, it's gone up 26.5 parts per billion. So it's skyrocketing, and it slowed down a tiny bit this week, but if we look at the highest that it was last year was on October the 12th of 2019. It was at 1885.75 right there on the chart. So we're not that far away, and then it started decreasing, but then it started coming back up, and it started coming back up in January. Actually, yeah, the lowest was at 1861.75, and then so it was coming up in January, and then it went down a little bit, and then it's the trend is upward. So we're only we're only 2 parts per billion away from the high that we reached last year, and it's only April. So if we look at last year, what it did, it was going up in March, and then it went down in April, and it went up and down, and then it didn't really start its increase until in July, and then it really started taking off. But it's already started taking off this year. So it looks like it's not looking good for this year. And down here, I've started tracking it on a daily basis, and here it is. Here it is from last Saturday, the 28th. It was at 1882.75, and here's what it did. It went down for a couple of days, and then it started coming back up, and then from the day before, from the 3rd, it went down 0.5 parts per billion. So in the last 8 weeks, it's gone up 20.5 parts per billion. So it's zipping along. So there's that. Now let's look at the methane on CAMS, Copernicus Atmosphere Monitoring Services. We have Sunday, April the 5th pulled up, the Arctic view and surface level. So here's where it left off. Here's the chart. Here's where it left off on Saturday. We're seeing this high release continuously right around Severnae Zemlya, and also it's releasing on this northern coast of Siberia and out of the Chukchi Sea and moving across, and high release over here off of the north coast of Alaska near Koktovik. So the data is for today, and the forecast period is Monday through Thursday. So let's see what the movie is. We're seeing a humongous release they're predicting or forecasting humongous release. Here's Tuesday, where it's moving out, and then moving out Wednesday and Thursday. But Tuesday is where it really starts spinning out. Watch this on Tuesday, this big burst and spinning out. So we're seeing this as a continual, and it's also populating in other areas now in the Kara Sea. And so we can see that methane is definitely on the rise now. And if we do have some valleys with it going down, I think they will be short-lived. Now let's look at the North Pole view. And we can see the whole northern hemisphere from this view. So we can see Europe's all covered up. Here's the Persian Gulf. Here's India. Here's the Indian Ocean. This is China. Here's North America. We can see the U.S. is pretty much filled up from the Midwest over. And we can see these waves of green moving out over the ocean. And look at this wave moving out through the North Sea. Watch this. Look at this arm. So it's really starting to take off. And we're just now moving into springtime in the northern hemisphere, and so as things heat up, we will start seeing methane releasing more and more. Here's the global view. And so what this means is methane is rising, is we will see more and more severe weather. We will see extremes, many more extremes in the weather. We will see more flooding, we'll see more droughts, and we'll see more of the superstorms. And so eventually it will get to where the weather will become so erratic that we won't be able to grow and store grains, and that's when it'll all be over. And we're also going to see rising temperatures with the shutdown of the industry around the world. Not sure how fast that's going to go. We already saw from Climate Reanalyzer that the northern hemisphere is up 1.1 C right now today, and the Arctic is up 4.1 C. So it's just hard to say. It's depending on how long everything is shut down, and how long it takes. And so here's 500 HPA. I'm going to refresh to get the right color ledger. So this is equivalent or close to the readings that we were seeing on NOAA. It was at 477 HPA, so close to that. A lot of dark areas, see up here, and it's pretty much red all the way across this northern hemisphere. and very high readings over China. Moving on up there. And now let's take a peek at total column, and I'll refresh so we can get the color ledger. Now this is where they add up the methane through all the layers to get the total column reading. And here it is over China, and even with their industry shut down for how many months, 2 or 3 months now, still huge amounts of methane coming up there. And here we have methane in India. We're seeing it moving out across the Pacific in this orange wave, and we're seeing high methane over South America as well. We're also seeing it peaking into the red here in southeast France, and spots of red up here in the northern hemisphere in Russia. So it's definitely on the rise. Now let's move on to sulfur dioxide. Now here is the global view from today for total column, and we've been watching what had been something like this that had been sitting over Canada for weeks on end, and now that's moved out and across the Atlantic and is now over the the Norwegian countries, and coming across Europe, moving into Russia. And so it's not from earthquakes. I'm thinking that it's from the sulfates falling out of the sky, and CAMS is picking it up. But some of this is from earthquakes and geologic activity, but I've been tracking this for weeks on end, and sometimes, or most of the time, I can tell the difference. I'm thinking this is from geologic activity in the North Pacific, because of this is where the tectonic plate is. Now this is at 500 HPA, so it tends to gather at this level and just hang around. Now this is a new release that we saw yesterday in China, or a gathering. It could be the sulfates falling down from China and Mongolia. We'll look at that in a little more detail here. Here's the Eurasia view. This is sulfur dioxide total column. So here's Novaya Zemlya. This is all Russia up here, and this is China down here. Here's Mongolia, and then here's Norway, Sweden, and Finland, and Russia, and here's Europe over here. So it's covered up in sulfur dioxide. Now here it is at 500 HPA. And the reason I say that this is not from earthquakes is because normally when I see it from earthquakes, it has a certain signature. It looks like an exclamation point. And this is just a weird, like Picasso painting. So here's the Pacific view. Now this is kind of an exclamation point, like what I'm talking about. It's upside down. Here it is at 500 HPA, and it's definitely, if we zoom in, this is, we can call that an exclamation point. So that could be from earthquakes, or this Wanda Fuca plate moving, and these tectonic plates moving. That could be from that. Here's the North America view. Now this has gone way down in the last few days. This is the lowest I've seen it in weeks. Here it is at 500 HPA. We see that there's nothing really outstanding here to really note right there. Here's the North Atlantic view, where this cloud, sulfur dioxide cloud, has morphed over across, and it's very slow moving. Here it is at 500 HPA. So it likes to gather at that level, and so I'm thinking that it's, like I said, that I think it's the sulfates falling out of the sky. Here is the European view. We can see all of Europe. Here's Spain. Here's where all these countries, European countries, are. Here's Russia. We can see it's just a huge mass of sulfur dioxide covering that area. Here it is at 500 HPA. What did I do? I think I got these out of order. Yeah, that's Europe. Okay, these are a little out of order. Here's the North Atlantic at 500 HPA. Alright, so here's the North Pole view. So we can see it. It hangs around. I think it likes the cold areas where it's falling, but it's falling down out of the cold areas, it looks like. And here it is at 500 HPA. This is just bizarre. Here's the South Pole view. That looks pretty normal and nothing unusual at 500 HPA. Here's the Searles Valley Ridgecrest area in Southern California from today. They had 42 this morning. And we're back to the beginning. The beginning of those pictures. Now, I want to show some sea ice. Do a little sea ice report. I haven't done one since March the 10th. So this is from the Navy website for today. They took it yesterday on the 4th, but it's modeled for today, the 5th. So this is the Arctic. This is the sea ice thickness for the Arctic. This is where it is today. And in purples, that's the thinnest. The dark purple is about 1 meter thick, and then as it goes down to the lighter and lavender color, it gets less and less. So we can see where all this purple is, that's under 1 meter. So all of that purple is going to melt real fast. And then this dark aqua is about 1.5 meters thick, like right in here. And then as it goes into the lighter aqua, that's about 2 meters thick. And then the aqua into the green, 2.5 to 3 meters. The green is 3 meters thick. The chartreuse is 3.5. The yellow is about 3.75, and we're seeing just a tiny bit of yellow here on this northern coast. Here, I'll zoom in. On the northern coast of Greenland and Canada, we're seeing a tiny bit of yellow, and then we're seeing a little bit of green, which is about 3 meters, and just a trace of red, and the red is about 4.5 meters thick. So we can see that the really thick sea ice is totally gone. So the majority of the Arctic is under 2 meters thick. So from this line all the way up here, the majority is under 2 meters thick. So as this melts, this will be the last to go down here, but that's just not looking good at all. Here's the animated GIF for 30 days from the Navy. It goes back 3 weeks and then it forecasts forward for 1 week. So it's forecast forward to the 12th. So we can see what's mainly happened in the last 3 weeks is the sea ice is kind of moving down from this northern part from Russia. It's moving down across towards Canada, and then it's moving out around Greenland and down through these tributaries. And so it's thickened up just a tiny bit in the 3 weeks. And then, but it's thinned tremendously around these coastlines. And we can see, like here, they're forecasting already no sea ice around the coastlines here, off the coast of Siberia there. That's within the next week. And it's retreated a whole lot here in the Bering Strait. So there's that. Now this is a movie I made. This is from NASA Worldview. Now they're having a problem with this model. They only had sea ice concentration up until March 25th. So we left off on March the 8th last time. Even though my report was on the 10th, the sea ice normally is about 2 days behind for them to get this model up, but they haven't updated it since the 25th. So this goes from the 8th to the 25th. So we haven't seen really what's gone on since then here. But the blue is thinner, it's less concentrated, and the white is more concentrated. So this correlates with what we were seeing on the Navy animation and the Navy picture, with it being quite thin up here around the coastlines, and that being the first to go. And also the melting and thinning here in the Bering Strait. You can see how it's really retreated just in that short amount of time. Okay, now let's move on over to this is the National Snow and Ice Data Center. This is sea ice extent. We want daily. This is for April the 4th, for yesterday, and we want concentration. And so this correlates with what we were seeing on the Navy website, and also what we just looked at from the NASA website, where the blue is less concentrated and the white is more concentrated. But we can see it's thinning over here in the Beaufort Sea as well. Now, down here, this chart shows the Arctic sea ice extent. That's the area of ocean with at least 15% of sea ice. And this blue line is this year, and we're at the lowest it's been at this time of year. And this dotted line was 2012, and before this year, 2012 was the lowest. But even with 2012, the extent being the lowest, it was much thicker back then. And then this gray line is the average from 1981 to 2010. So it's not looking good. While we're here, we can look at the Antarctic. Here's concentration. Now the sun is about down. It'll go down. It's almost, it's at the horizon, and it takes a while for it to go down completely. It'll be down in another week or so. But it's getting dark down there, and so we can see the sea ice is starting to come back, starting to grow back like it's supposed to when it gets dark. And here's the sea ice extent for the Antarctic, and the blue line is this year. This gray line is last year, 2019, and so it's up higher than 2019. It's actually at it's running along the line of 1981 to 2010 average. So that looks better, but anyway, it's still not good. Now, here is, we can just take a little tour of the sea ice here today. This is from NASA Worldview for April the 5th, 2020. Here's Greenland, and we can see, now we saw on the model that there's no ice around this bottom part here. This is Baffin Bay. It's got some thin ice in here. See? And part of this we're looking through clouds. So once you get used to looking at this, you can tell when you're looking through clouds and when you're looking just at this, you can see the sea ice through the clouds. Like here's the edge of the sea ice, and this is clouds over here. Here's Svalbard. Here's the edge of the sea ice coming out. This is Novaya Zemlya. I thought there was no ice here. I guess there's a little skim there. Let's see. Now you see these lines going along? That's where icebreakers have gone. That's why it looks so thin. You can see the trail where they've gone through and made a trail through for the ships. So we can see the sun is up here. It'll be up all summer long now. Now here we can see this is ocean here. Here's here's where the ice is broken up. We're looking through some clouds here, but I wanted to show you where all that methane's coming up. It's right around this group of islands. This is Severni Zemlya, and it's been coming up here from this tippy point and then moving up here, moving around. There's another area that's been bubbling up over here, and this, we have a lot of glaciers, ice caps, and this Vovolov is the one that's been melting, that we can see. When the sea ice goes away, we'll be able to see the glacier just pouring into the sea there. That's quite thin there. Here it is around the edge. You know, that could have been from icebreakers too. I just don't know. Now look over here. Now this is over this this East Siberia ice shelf or Arctic shelf. It runs all along here. And this is the area where Natalia Shukova did her research and found that the huge methane stores were buried in the sediment off the coast here. And she was worried about if it gets warm enough, if the water gets warm enough here, then the methane bubbles will just keep coming up, and we could have that 50 gigaton burst of methane. So we haven't seen that yet, but we're seeing I don't know how much is leaking over at Severni Zemlya. Nobody's saying, and we can't really get totally accurate readings over there because we're not scientists. But we can see that this sea ice is already well on its way of being melted. Look at this area. And it appears that there's a tiny ice shelf that's hooked onto the coastline. And then like right here and out here, and then here's the sea ice over here. It's already very broken up. This is very thin, and this is the area that was in the purple on the navy picture that I showed you. And we can see here, this is what, there's no clouds here. That's a really good view. See, here's the ice shelf. I call it an ice shelf. And then there's a big line running where you can tell it's separated. And these are the leads between the ice where it's melted in between. So this is Russia, here's Alaska, this is the Bering Strait. And there's some sea ice. Looking through clouds there. So here's Alaska. Here's Barrow, that's the northernmost tip. And right down here is where we were seeing all that methane coming up over and over and over. Now, they do have some offshore drilling operations up here. I'm thinking it could be from that. You never know. So then, the thickest area is right along here, from the northern part of Greenland all the way across Canada here. And it's not very thick. I mean, not compared to 20 feet like it used to be. And we can see that it's not solid. It's already cracked here. See, even where this thickest ice is, it's already cracked. Let's see if there were clouds here yesterday. We can see a little bit better here. We're looking through clouds, but we can see that that's probably pretty thin right there. So we can see this ice a little better here. Look at that. With so much sulfur dioxide all across the Arctic, if it snows or rains, it'll come down like sulfuric acid in the snow and rain, and it'll be eating up the sea ice even faster. And we can briefly look at the Antarctic. Now, this big black area, that's where the sun is going down. So we can't see that area. Now, let's see where my favorite iceberg is. There it is. There's some storm clouds. This is A68 that broke off of the Larsen Sea ice shelf a couple of years ago, right down here. And it's been making its way, but it's headed out to sea. Let's go back. See if we can find a good day where we can see that. There he is. We're having to see him through clouds. It's right there. It's still really intact. Now, it used to come out like this, so it's broken off, been breaking off somewhat. But it's well on its way. It's headed out to sea. Totally free and clear. It's got a mind of its own, I think. There it is. Oh, that's a good view. Look at that. And look at this. Anyway, there he is. How would you like to ride on that? Take a tour. But you can see pieces breaking off here. And I'm thinking as it gets into warmer water, it'll start breaking apart. They ought to capture that for water, because that's fresh water. Because it was on the ice shelf. It was up here. Right here. I think it's fresh water. I could be wrong. Okay, here's today. Then down here is Pine Island Glacier, and we saw a huge area calve off in the last month or so, and it's still been breaking off, and see, it's very jaggedy. Now this used to come all the way down here, and it's been breaking off more every year. That looks very strange. Let's see. Here's a better picture. So this is where the ice is coming back. This is like greasy ice, they call it. Grease ice. I can't remember. Grease ice? Something like that. But look at the striations. It goes on up over there. Wonder if that's clouds. You know, it's just another Picasso painting. Let's see. Ice surface temperature. That must be clouds. Okay. Because we see the ice surface temperature where there are no clouds. Okay, I was wrong. So that was strange. Let's go back to the 5th. Here's Ross Ice Shelf. It's in the dark now. Then the other big iceberg that broke off was this D28. It's right here. It broke off over here where you see this line. That's what broke off, and it's moved here in the last few months. So these are clouds here, and then this is sea ice out here. Where the colors are is where the ice is. But it's a strange color because of the angle of the sun. It's right on the horizon. It's just barely up. Now, one thing that did not happen this year that I thought would, oh, look at that big chunk. Over here, I thought that this was going to break up. This has been cracking here. I am not remembering this ice shelf. I'm just drawing a blank right now, but we can see that there are lots of cracks there. The brunt ice shelf. I'm shocked that this didn't break off this year with the sun up. This is where they had to airlift the scientists and researchers off of their research station because the crack was coming across, and there's a crack here. So it's still breaking up, but it's still intact, it looks like. So I'm surprised that didn't happen when the sun was up. So there's that. Now I have an article. This is from Sam Carana. Let me get a drink of water. Arctic-news.blogspot.com. This was posted on March the 17th. And this is about methane. Okay, the title is Methane, Earthquake, and Sudden Stratospheric Warming. So, and I showed this when I was doing my daily reports for my Subscribe-Star members. This is NOAA reading for the 477/469 millibar reading. This is from the Met-1 satellite in the morning on March the 12th. And the mean was 1883 and the high reading was 2902. It was very high, 2,902 parts per billion. Now, how would you know where that was unless you were on the inside and you knew where it was? So he says, on the morning of March the 12th, 2020, peak methane levels were as high as 2902 parts per billion at a pressure level of 469 millibar, equivalent to an altitude of some 6 kilometers, almost 20,000 feet. What did cause this very high peak? The image on the right shows the situation at 695 millibar. So this is at a different millibar, 695. So he says high levels of methane colored in magenta show up over the oceans at high latitudes north, especially around Greenland and Svalbard. Okay, Greenland and Svalbard. The image underneath on the right shows methane even closer to sea level at 1000 millibar. At this altitude, such magenta-colored high levels of methane only show up over an area in between Greenland and Svalbard. I can't even see it. I guess it's right there. I can just barely see it. It appears that these high methane levels did originate from this area. What could have triggered this? The image below shows that an earthquake with a magnitude of 4.6 on the Richter scale hit an area in between Greenland and Svalbard on March 11, 2020 at 21:30:03 UTC at a depth of 10 kilometers. Now we know that when it just says 10 kilometers deep, that the USGS, that's their default for the depth. So here it is, the earthquake, 4.6, right there next to the red line. It appears that the earthquake did cause destabilization of sediments at the seafloor of the Arctic Ocean in between Greenland and Svalbard, containing methane in the form of hydrates and free gas, with the destabilization resulting in the eruption of methane that subsequently reached the atmosphere. As illustrated by the image on the right, there were strong differences in pressure in the atmosphere over Greenland on the one hand and over the Arctic Ocean on the other hand on March 11, 2020 at 2100. So here's this. So we're looking at this area here and this area here. The next question is if there was something that triggered the earthquake. The image below shows a forecast for March 22nd, 2020 of conditions in the stratosphere at 10 HPA. So, above image shows a forecast for March 22nd of temperatures as high as 6.2 C or 43.2 Fahrenheit and as low as minus 68.8 C or minus 91.9 Fahrenheit at another location at 10 HPA polar vortex with wind reaching speeds as high as 369 kilometers per hour or 229 miles per hour. So here's our high winds. That's really high. This indicates a strong updraft carrying huge amounts of relatively warm air from low altitudes over the Arctic up into the stratosphere. Following a steep fall, Arctic sea ice extent was at a record low for the time of year on March 28th, as illustrated by the image below. And there it is. And we saw it that it's low. And it's been low since March. Since the 1st of March. Since the start of 2020, Arctic sea ice volume has been at a record low for the time of year, as the image on the right shows. Here it is, right there. These conditions may have acted as a sink plunger, triggering the earthquake and destabilizing sediments at the seafloor, resulting in the methane eruptions. More generally, the events reflect a huge and growing overall imbalance in the temperature of the atmosphere, and the added methane releases further contribute to this imbalance. Meanwhile, sea surface temperatures off the coast of North America on March 21st were as much as 13.2 C or 23.7 Fahrenheit higher than 1981 to 2011, as the green circle on the image shows, right there. With sea ice thickness this low, it looks like there will be no buffer left to consume ocean heat that gets carried along the path of the Gulf Stream into the Arctic Ocean, which threatens to further destabilize sediments containing huge amounts of methane, as also discussed in an earlier post. On top of this, high temperatures keep showing up over the Arctic Ocean in forecasts, as illustrated by the two forecasts below for March 21st and March 31st. So this could be why the methane is coming up up there where we're seeing near Severna Zemlya. Now that's not far from Svalbard. So here's Climate Reanalyzer. He ran a forecast, and it was showing the Arctic at up 3 point, I can't read that, 3.6 C, but it's 4.1 C today, higher than normal. And here, so that was for the 21st, and here for the 31st it was 2.0. Discussion. Okay, we're almost done with this. As said above, it appears that this magnitude 4.6 earthquake on March 11th, 2020 caused a destabilization of sediments at the seafloor of the Arctic Ocean in between Greenland and Svalbard. The image on the right shows that earlier a magnitude 5 earthquake hit an area a bit to the north, i.e. on March the 3rd, 2020. While not much methane showed up locally following that magnitude 5 earthquake, high methane readings were recorded elsewhere over large parts of the Arctic Ocean early March 2020, which could have resulted from destabilization along the fault line that crosses the Arctic Ocean, the red line. The next image on the right shows that earthquakes between Greenland and Svalbard over the past decade did predominantly occur on this fault line. The high methane readings in between Greenland and Svalbard following the magnitude 4.6 earthquake could have occurred for the very reason that the earthquake hit an area outside the fault line where sediments had until now rarely been shaken. This could imply there could be huge amounts of methane contained in areas outside the fault line, supporting the above warning that ocean heat that gets carried along the path of the Gulf Stream into the Arctic Ocean threatens to further destabilize sediments containing huge amounts of methane. After all, such destabilization can occur as a result of higher temperatures or changes in pressures or both. And that's the article. So we can apply this to what we're seeing then on cams, I think, where we go, okay, surface level, and we go up to the Arctic. So the area he was discussing was right in here between Svalbard and Greenland, but this red line comes right up here. And so the methane, we've been seeing some earthquakes up here this spring as well, or actually January and February. There were some up here right on the red line. The red line comes down here, and so the red line is not too far from this area where this heavy methane release is coming up continuously. So it looks like something got disturbed, and we're going to see more and more. So speaking of earthquakes, so we can see the area that he's talking about that he showed was right here. Right here between Svalbard and Greenland. Here's the red line, and then it goes up and then comes around and back down over Russia. And so Severnae Zemlya is right here, the area that's where all that methane's coming up. So it's a little bit off, it's a little bit to the west of that red line. Makes sense to me. And then we've had some earthquakes here on the coastline in the last few months. So let's move on into the earthquake part of the report. We're seeing 631 earthquakes worldwide for all magnitudes here. The majority of them are up here in this Anza region, so we'll be anxious to look at that. Let's start down here in South America. 4.5 in Chile, 4.4 Chile, 4.5 in Peru, 4.6 in Colombia, 4.7 in Ecuador, 4.7 in Bolivia, 4.7 in Peru, 4.7 in Chile, 4.7 in Colombia, 4.7 in Peru, 4.7 in Chile, 4.7 in Chile, 4.7 in Peru, 4.7 in Colombia, 4.7 in Chile, 4.7 in Peru, 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 4.7 in Chile, 4.7 in 4.3 Chile, 4.6 Chile. Then over here in Indonesia, or Solomon Islands, of 5.0, 4.5 Papua New Guinea, 4.6 Papua New Guinea. I've got to zoom in a little bit. Here's a 4.3 East Timor, 4.9 Indonesia, 4.7 Indonesia. Here's a 5.9 Indonesia, and a 4.7 Indonesia. So this is a lot of activity right down here. 4.6 Japan, 4.7 India, and a 4.5 Afghanistan. So those are the international earthquakes. Now let's look at Hawaii. They've got 22 here today. These are in the 2s range. 2s and 1s. And then over here at Puerto Rico. Here's a 4.1 at Rincon, Puerto Rico. What else have we got? We've got 36 here today. So the 4.0 or 4.1, that was the highest one, it looks like. The rest are in the 2s range, it looks like. Now in Alaska, there are 54 here today. We've got a 3.9 at Amatignock Island. That's the highest one. These are all fairly small, like in the 2s. 2.0 Willow, that's near Anchorage. 2.0 Sutton Alpine, and so forth. Then down here in the lower 48 is where it's really rocking. We've got 505 earthquakes here in the last 24 hours. Here in Oklahoma, they've got 4. 2.7 is the highest. Here in southern Utah, they've got 3. Here's another one near Salt Lake, a 2.7. Now up here, this is where we had the 6.5 in southern Idaho, near Boise. So let's see, in the Yellowstone region today, we've got 27. And most of them were over here at Chalice or Cascade. 3.6, so 2s and 3s. 3.8. So 25 right there. That's after the 6.5 hit. Now look at all of this up here in Washington. Got quite a few. Here's one at 0.5 at Eatonville. That's just at the base of Mount Rainier. Got a couple by Seattle and then 2 over there. Now let's come on down. Now Mammoth Lakes is coming back to life. They had a 4.4 here at Tom's Place, California. That came in at 12:20 this afternoon Pacific time. And we haven't seen one that big here in a while. But that got the movement started. There have been 9 here. And this is in the Mammoth Lakes area. which is part of this long valley super volcano caldera. We got these red ones are new, 1.7 and 1.0. We've got some couple up here at Reno and Carson City, just a couple down here through Nevada. Here's the Searles Valley Ridgecrest area. Now yesterday, or night before last, was when we started seeing this huge shaking down in Southern California. Now this is Los Angeles here, San Diego here, and it's in between there, and it's up to the northeast of San Diego in this Anza region, just to the northwest of Salton Sea. And we've got 377 here today. That's insane. Who ever heard of that many? 377. So it's still rocking. I don't know what's going on. I don't know. Unless it's all cracking. Let's see. 2.5 magnitude or higher. We've got 9. So most of them are under 2.5. So in the last 24 hours, the largest one was a 3.5 here. But we saw a 4.9 down here 2 nights ago. I think it was a 4.9. We still got huge movement here. So this could be part of this slow slip of the plate. Oh, here's a new one. 2.5 at Tom's place. So this line, this is the San Andreas fault line running all the way down. And here's the Juan de Fuca plate. And here's the Cascadia subduction zone that we're so concerned with. So we're going to keep reporting and watching on this area down here. That's crazy. The show's getting kind of long. So that's all I had for tonight. So now let's hop on over. And we're on chapter 64 in Isaiah. We're almost done with Isaiah. Oh, that thou wouldst rend the heavens, that thou wouldst come down, that the mountains might flow down at thy presence. As when the melting fire burneth, the fire causeth the waters to boil, to make thy name known to thine adversaries, that the nations may tremble at thy presence. When thou didst terrible things which we looked not for, thou camest down. The mountains flowed down at thy presence. For since the beginning of the world, men have not heard, nor perceived by the ear, neither hath the eye seen, O God, beside thee, what he hath prepared for him that waiteth for him. Thou meetest him that rejoiceth and worketh righteousness, those that remember thee in thy ways. Behold, thou art wroth, for we have sinned. In those is continuance, and we shall be saved. We are all as an unclean thing, and all our righteousnesses are as filthy rags. And we all do fade as a leaf, and our iniquities like the wind have taken us away. And there is none that calleth upon thy name, that stirreth up himself to take hold of thee. For thou hast hid thy face from us, and hast consumed us because of our iniquities. But now, O Lord, thou art our Father. We are the clay, thou our potter, and we all are the work of thy hand. Be not wroth very sore, O Lord, neither remember iniquity forever. Behold, see, we beseech thee, we are all thy people. Thy holy cities are a wilderness. Zion is a wilderness. Jerusalem is desolation. Our holy and our beautiful house, where our fathers praise thee, is burned up with fire, and all our pleasant things are laid waste. Wilt thou refrain thyself for these things, O Lord? Wilt thou hold thy peace and afflict us very sore? Isaiah chapter 64. So they're begging for mercy now. So I'm going to go ahead and sign off, and just telling you that I'm praying for everybody and hoping that everybody gets saved who's going to get saved. I wish everybody would get saved, but that's probably not going to happen. But I'm praying for everyone, and time is very short, so keep your eyes on the sky and on God and Jesus. And God bless you, and go in peace, and sleep well. I will talk to you soon. Good night.